Hi, good afternoon. My name is Mailson. I'm from Brazil. I'm from Uniju University. Today, I will present a tool called Jabuti CE. Jabuti CE is a tool for writing executable smart contracts in the context of enterprise application integration. So we cannot use Jabuti CE to write smart contracts in any language or for any blockchain. We can use Jabuti CE just for writing smart contracts written in Jabuti DSL. This DSL is a domain-specific language for enterprise application integration. I will explain this a bit more in some slides. Jabuti CE and Jabuti DSL, they are below of the Jabuti project. This project currently is composed by 8 people. Me and Eldair, we are the PhD students. Rafael Zefrantes, he is the manager. Sandro and Fabricia, they are from Uniju University as well. José Bocanegra is from Colombia, from Universidad de Los Andes. Antônia Reina Quintero is from here, from Seville University. And Carlos Molina Jimenez from Cambridge University in United Kingdom. My presentation is divided in 4 sections. First, I will explain a bit more about the context. I will introduce Jabuti DSL. I will explain how we can use a smart contract in integrations. In the second section, in the problem section, I will explain although we can use the smart contract written in Jabuti DSL, we have a problem. I will explain more in this section. In this solution, I will present the Jabuti CE tool. I will present the main feature, and I will present a little demonstration. And finally, in the last section, I will present 2 things. One, what I am doing in this moment, and 2, some topics that we want to explore in a couple of months. Firstly, we need to keep in our mind that if we talk about enterprise application integration, obviously we are talking about 2 or more companies, and these companies want share or data or functionality. And this process of sharing is made by an integration process. This integration process usually is made in platform integration. And if we look for this workflow, we will see that we can break this process in 2 small pieces. If we look for the communication between the company A and the integration process, or the integration process and the company B, we can break this workflow into small pieces. We can see this process of communication as a bridge. So the data from the company A walks into the integration process through this bridge. As we are talking about companies, this data is below some rules, some policies, because they needed to be in compliance. In this moment, we can note that we have 2 parts, the company A and the integration process, and we have a set of policies. This is a structure of a smart contract. If we are talking about the integration of in the companies, we can use Jabuti DSL to write these smart contracts, because Jabuti is a specific language for this context. But we have a problem. Which problem? It's possible to execute the smart contract written in Jabuti DSL? The answer is no. if we can't execute the contract is useless. So we need to find a way of execute the contract and becoming it useful. So how we can execute the Jabuti DSL smart contract? We have two options. The option one, build a runtime. And the option two, transform the smart contract into a executable language. The option one is not a good option because we will need first develop the runtime. This is complex. It's a complex task, and we will need much time to develop the runtime for execute the smart contract. The second problem is, okay, if we develop the runtime, we will need to support this runtime because any software in a moment will give us some problems, some bugs, for example, and we will need to support this type of problem. The option two is better because if we use the process of transformation, we will transform into a validated language, and this language will be executed in a validated environment. Will be more easy, will be much easier, much faster, and we will have more possibilities than if we were using a runtime. For example, if I build a process of transformation that allows us to transform the Jabuti DSL contract into a Hyperledger contract, I can use the Jabuti DSL smart contract for Hyperledger Fabric. But if I develop the transformation for Ethereum, I can use the Jabuti DSL smart contract in the Ethereum virtual machine. And I can do this for any blockchain. I have already responded this question. In this point, we know that we can use Jabuti DSL smart contract, and the best option for use it is make the transformation. But I need to deliver this transformation of some way. I need to allow the user use the transformation. So we have chosen make this by a VSCode plugin, and we have called this plugin of Jabuti CE, Jabuti Contract Editor. Why we have chosen VSCode? Because firstly, VSCode is the most used code editor in the world, and secondly, because VSCode, we have the feeling that it's much easier for a non-IT user to learn how to use VSCode than other solutions like Eclipse, for example. In this moment, Jabuti CE is in the version 0.0.5, but we are always updating it. So if you go in the VSCode marketplace, you will find the Jabuti CE. Before I want to do another slide, we need to keep in mind that, okay, I can use the plugin to transform the Jabuti DSL smart contract. But I cannot transform the smart contract if it has some spelling mistakes. So I need to provide some features that helps the user to write the smart contract without any spelling mistakes. So the main features that are delivered by the plugin is, one, code highlighting. The code highlighting is the ability of give colors for each code blocks. For example, in this picture, we have the contract keyword in blue. we have the dates keyword in green, parties and variables that are in the same level of date are in green as well, and due date is in pink. So the code highlight allows the use quickly and in a simple way, read and find and code block in the contract. Autocompletion is a common feature because it's a feature when if you have a part in a file and in this place is expected a default value, if the user press Ctrl plus space, all available options are showed. The next, maybe the most important for us, is the syntax in the semantic validation. In this picture, we can see that below of the begin date keyword, we have a red line. This red line indicates that there is some mistake. If the user holds the keyword, a message explaining the error is showed. In this case, it's because begin date is a required value and it is empty. But for example, if begin date was had a value and this value was in a non-allowed pattern, in this case, the message would be, for example, begin date is in a wrong format. The last feature before the transformation is the documentation. In the same way of the last, you can hover a keyword for see the message error, or you can hover a word to see a small documentation. The first phrase is always a short description. After this short description, we have a short allowed patterns, and after the allowed patterns, we have some examples how we can fill in it. Finally, we have the transformation. The transformation is our main goal because using the transformation, we can, as I said in some slides ago, we can use the smart contracts in real scenarios. For use this feature, you just need to click using the right button in the smart contract file and click on transform to Hyperledger Fabric using Golang in this case. The next slide, I will show a small demonstration. In this demonstration, I will show the transformation of the smart contract and the execution of the smart contract in a local testnet in Hyperledger Fabric. In this case, I am using Spider. Spider is a plugin in VSCode. It allows us to build a local Hyperledger Fabric network. In this moment, I am doing the deploy of the smart contract. The smart contract was deployed. This is automatically. I just need reinitialize the plugin. This is the contract transformed. And now I am doing the execution of the smart contract. So this proves that we can write the smart contract using Jabuti DSL. We can transform the smart contract into executable language, and we can execute the smart contract. I have consulted the client ID. I am using the same because it's just a test environment. The contract was initialized. Was signed. Was carried. And finally, a clause was executed. Talking about current and future works. We have some challenges. What challenges? First, we have made some steps. We have the DSL, we have the plugin to transform the DSL. We have evaluated the execution of the transformed smart contract. But we need to automate the process of integration. We need to automate the process of integration between the transformed smart contract and the blockchain. We need to do this test. Second, if we integrate the smart contract in the blockchain, we need to monitor and execute the smart contract of an automatized way. Why? We want to add a smart contract in a process integration workflow. So we need to execute the smart contract in the blockchain, but we need to catch the response of the execution and use this response inside the workflow. So because of this, we need to monitor the execution of the smart contract. We will explore in some moment how we can use AI because, for example, maybe we can use AI to help us automate some transformations because today we have made this by hand. And finally, we need to explore more complex case studies. I am doing this in this moment. I am creating some. I am creating more complex networks. I want to use more. How can I say? I want to use case studies more complex, and I want to use blockchain with more nodes. Finally, where do you can find us? We are organizing all the projects in GitHub. So if you want to learn the project, if you want to read some paper we have published, you can find this in the GitHub repository. If you can analyze the code, is available. If you have some doubt, there is a documentation in the repository. And we are working with 4 repositories in this moment. One is written in Xtext and Exchange, and the other ones are written in TypeScript. So you can choose all of them, for example, and they are available. That's all. You can see this smart contract. Yeah.
I saw something about some dates.
Yes, I have. A moment. We have a repository called Jabuti CE Transformation Engine. In this repository, we have a folder called samples. So in this folder, always we'll have some samples. This is the contract I have executed in the video. In this smart contract, I am simulating.
Can you explain what it means or what it's about? I'm just trying
Yes.
to understand the context.
Yes. In this case, for example, imagine that you are buying something in some marketplace, and the marketplace they have the following rule. They agree with you a delivery date. If they deliver the product late, they will give you a gift, for example. So after you buy a product, the system of tracking will manage the delivery. When the delivery was finished, the system tracking will send an event, and this event will trigger the smart contract execution. If the delivery date is bigger than the expected date, the clause of this contract, for example, the clause of purchase between $100 and $300 will be violated, and this will trigger an event into the system, and this event will trigger the gift that will give for you. Will be given for you. For example. Our first implementation is using Xtext. But before of the first implementation, we have implemented more 3 repositories, and the first repository is deprecated. All implementation of this first is in TypeScript. So Jabuti CE is in TypeScript. The grammar of Jabuti DSL is in ANTLR-4, and the parser is generated in TypeScript. The VSCode Plugin, of course, is in TypeScript. And we are developing the monitoring tool. Maybe this tool, we will use Golang, because our goal is integrate the monitoring tool with Hyperledger Fabric. Okay.
Another question? I have a comment in general. So, because I guess you are new in research somehow. You are doing your master's thesis first, and I'm going to advise somehow, in the sense that very often we start developing tools and languages or plugins, but we don't explain very well why you are doing that. For example, I missed from your presentation, and that's an advice for the future, to say why yet another language for, if I have the transformation for another language that you can run the smart contract, why you are inventing a new language. I'm sure that there is a rationale for that, but it's good to, when you present something, that say why is this needed, why you are proposing a new language, because the context is different, because if you try to write the smart contract in the target language, then it's more difficult maybe. And if you can, in that sense, have some validation, some evidences from practitioners, from students, from researchers, it's good. So not going directly straight to the implementation, but motivating a little bit more. Why is that? Maybe you can add that. We still have some time if you want.
Yes, I didn't add this part because I didn't add this part because the main focus was the process of transformation and the execution. But why we have made another language and why we have not used Solidity or Golang, for example? Because the first point is a non-IT user cannot use this general language in business process. This is the first point. The second point is, okay, we can use Solidity, for example, but some kind of data we cannot put in Ethereum because it's a public blockchain. But if we use Hyperledger Fabric, the project will be coupled in the blockchain. So if the blockchain, I don't know, was deprecated or stopped of working, our project stopped of working as well. So these two reasons were the main reasons for us to develop a new domain-specific language. It's a good question because all days be born more than 20 domain-specific languages. So we need reasons to build a new one.